What really happens when you type in the following GCC command? Well, the compilation process is a 4-step process. First, we have the pre-processing step, but we will get back to that. The compilation step, it takes your C input file and transforms it into assembly code. The next step will take that assembly code and assemble it into raw machine instructions that your computer can understand. And then at the linking step, you take that machine code and you add different libraries, and the output file is an executable, like an exe file or an ELF file. But what about the preprocessor step? How does that work? Well, that is what this episode is all about. We are going to code our own preprocessor. So let's begin. Sup guys, welcome to today's show. So today we're going to code our very own C preprocessor. And I'm going to show you what I mean by that. So if I create a temporary file, okay, I already had one like with that name. Let me just clean this out. Alright, so let's say we have a very simple C file. With something like constant, and then we have some value that we take from the constant, and then we quit. So this constant, this can be defined using this syntax. And this is also called a macro, even if it's more the function variant of this that is called a macro, but this too, I guess. So what we do is we define that a constant is 5. And what this does is when the compilation process begins, it will first run the preprocessor, and that means all the different commands with an @ sign at the beginning. A hash sign. So this include directive, as you probably already knows, means that we open this file at a specific location where all these files are located. We take the entire contents of the file and we paste it in here instead of this include line. And this define, what it does is it defines this constant to be 5. So at every iteration in the program or every place, this constant will be replaced by 5. So if we compile this thing, this will be the result. And the C propress, it's difficult to pronounce. The C preprocessor is called CPP. So that should not be mistaken for the C++ compiler, which is called G++. So CPP is the command to just run the preprocessor. It's a little bit difficult to see though, because if we have those include lines. So let me remove this temporarily. And then we run cpp a.c. And this is the result. As you can see, the constant has been replaced by 5. So if you are debugging some advanced macros or something, the cpp command is very useful. But remember to comment out the includes, otherwise you get input like this. which is not very helpful, right? Alright, so what different instructions are there? Well, we have the include, and there are two different syntaxes. We can do include blah.h like this, and then it will go to a central location on a Linux system that is user include and some subdirectories there. But if we want to use our own, we can do this syntax instead with the quotes. Then it will go to the current working directory and locate that file. And then we have the define, which I just showed you. You put an identifier here and then a 5 or a string like ABC or whatever, and it will be copy pasted into the right place. You can also create a function-based macro, which looks like this. So this means that when we run ABC with an argument x, we should instead run printf with an argument x. We are not going to support this in this version, but we will in the later versions, because the reason I want to code my own C preprocessor is because I'm not really satisfied with these function-based macros. I want to have the ability to create, for instance, my own operators. So what is an operator? Well, if we have, for instance, if A is equal to X, this equal sign is an operator. What possibilities do we have currently to create something like that? Well, it's not pretty. Let's say, for instance, I want to create this, like some languages have. So this is a strictly equal sign. What it means in programming is that A is equal to X, same as here, but A and X are also the same data types. So let's pretend that we have a function which is called seq for strictly equal. So let's say we have a bool. So this is a boolean, returns true or false, strictly equal, and we have let's say int 32x and int 32y, just to have something. And I'm not gonna put the code for this here because that is not the point, but I wanna be able to call this function. Well, I can call it like this: if strictly equal a x. That's a possibility, but this is not what I want. I want this much cleaner thing where we have an operator and then we have the two two values of the comparison at each side of this thing. So what if we were to create a function-based macro of this? Well, what we can do is we can do something like define, let's say this is seek prime then. So define seek, and we have an x and a y, and we want to call seek prime with the same x and the same y. However, this creates the same thing, right? We still need to do this. But we can do it in multiple steps, so it becomes a little bit better. We should be able to do, for instance, something like eq, what did we have, a and x and if. And how would this work? Well, instead of doing a function-based macro, we could define eq to be seek prime parentheses. And then we could define endif to be the ending parentheses. And then we could do this, but it's not pretty, this either, right? So it's a little bit tricky, this thing. I haven't been able to deduce any good way of doing this in a clean enough kind of way, unfortunately. So that's something I definitely want to support in my own preprocessor, because it shouldn't be too difficult, right? The only thing we need to do is, if we have an A and a B, we want to turn them, or if we have a function call of A, B, we just want to rearrange things. So we do A, C, B instead. Shouldn't be too difficult. But first we need to implement the function-based macros, which we will do in the next version. However, I'm considering supporting pragma once. What does this do? Well, when you include some .h file, sometimes you might try to include it from different C files, and it might conflict. So if you put this pragma once at the top of the .h file, it can only be included from one file in the compilation process, or once per compilation. This is, we used to do it something like this. We could say that if defined, and then we had some constant, and if this, if not defined, then this constant, then we were to define this constant, and then we have our entire .h file, and at the end we have endif. So the first time this runs, the constant is not defined, and then it will be defined, and then the rest will run. So now it is defined, so the next time this code runs, this will not be true, and nothing will run. So this is the same as this. This is only cleaner, a new version, so to speak. But I do want to support this, though. So we can check if a constant is not defined or if it is defined. Why didn't this work? If defined. If defined. This. Okay. So these are the different things that I do want to support. And let's get to it. I have created a directory which I called CPP, C preprocessor, and we are going to use one of my libraries as a base, and I'm going to show you how to include it in the project. So if we go to repo drbirch.com and we go to birch utils, this is a utility function collection that I use. So I don't have to redefine the same functions in episode after episode. And you go to version 1.3 and you can download the zip file. And I have already prepared, so in my project directory I have this birch utils. So let's unzip this thing. And I will delete the zip file. So now we have a birch utils subdirectory. And one thing that we might have to change is, let's see, this right here. So if you're running an old GCC, you might need to remove this part because that standard C2X is not supported. And if you run the absolute latest GCC, like version 14, then you can actually use C23 here instead, which I will do. And I'm not going to install this globally this time. I'm just going to compile the thing, and you just run make and it will compile. So now we have this SO file, but we also have this .o file that we can use to include it directly. So we don't have to worry about installing libraries globally. Okay, so let's open up this folder here in VS Code, and since I'm coding remotely against my Linux server, I'm going to use the Sociopath SCP client to remotely open up this folder. So I'm going to make sure that VS Code is selected here, and I'm going to my TMP and my CPP directory here, and open in editor. I right click and open in editor. And after just a small moment, we can minimize this. And now it's open here. And if we edit something or create some file, it will automatically update on the server. And make sure to close this Copilot bullshit so you don't get disturbed by it. Alright, so let's see. Let's create a new file inside of the CPP directory. Now I got it the wrong way, I think. You need to click on this and then new file. Okay, I think this is right. So let's call this cpp.c. And this time I'm not going to worry too much about creating data structures and structuring everything perfectly. Let's just start coding this thing and see where it goes. So this is the cpp.c, and I want to include let's see. We want to include two things. I'm going to include cpp.h, which is an H file I'm going to create. So let's do that. cpp.h. So we have a little bit of structure at least. cpp.h, and in here I'm going to include stdio. I'm going to include birch utils / birch utils.h for the library, and that's it. I also want to define some integer types, so let's do a typedef. Alright, so I'm going to define some integer types to make stuff a little bit cleaner. So let's start with unsigned char is going to be an int 8, so that's 8-bit. I'm going to have an unsigned short int, which is an int 16. I'm going to have an unsigned long int, which is int 32. I'm gonna have an unsigned long int, which is an int 64. And I'm also going to create some aliases or macros for converting between these types. So I'm gonna have a $C to convert it to a char. I'm gonna have a $I to convert to a regular int. And then I'm gonna have one for 1 byte, which is an int 8. I'm going to define int 16, 4 bytes for an int 32, and finally 8 bytes for int 64. And why do I create pointers for the characters and the int 8 but not the other ones? That's just because I usually use these with integer types and I use these with strings. So that's why. Okay, so how do we do this? We need to create some kind of parser which is able to interpret our file. So basically we want to parse, so we find this hashed sign in the beginning of a line, and then we activate, so we check what command it is. And if we don't find this, then we just propagate the lines as is. We have one thing additionally though. So let's say we have a macro ABC with an X. We're not going to have that, but just as an example, because this works the same with regular things. So let's say we have two commands that we want to run when this happens. We want to run printf(x), and we want to run, I don't know, exit -1. So what happens in the inner workings of the preprocessor when we do this? Well, what it does is, first of all, it removes this white space. It removes the new line and the slash, and it adds one space in between. So we should also have this, right? And not there though. Okay, so we need to check if the line ends with a backslash. And there might be some, it could also be something like this, where we have a couple of spaces here or whatever. That should be treated the same. So if it ends with a backslash or with a backslash and white space, so we need to have a function which identifies is it white space or not. So let's start in that end. Yeah. By the way, we need to have a main function, so maybe we should define that. And what are we going to call this function? Maybe just white space. So it's going to be a bool, and in order to get access to bools, we need to include stdbool.h. Bool, that's a funny word, by the way. Bool. Alright, so bool white space, wild space, white space. And this is going to take an int 8 star, or no, just an int 8, so one character. And it's going to return true or false if this is white space or not. Okay, so let's, by the way, just define a main function. So we have that done. Alright, so how do we create this function? It's going to be bool white space, and it's going to take an int 8 character, and it's going to be pretty simple. All we need to do is a switch statement. So we switch for the C. In the case of a regular space, we return true. In the case of a new line, we also return true. So what else do we have? Tab. This is tab. We return true. What else? Is there something else? Space, new line, tab. I thought it was 4. Let's check one thing. If we do man_tr, that's text replacer, and we search for white space, all horizontal or vertical white space. It does not define what white space is, though. Well, let's define it ourselves and decide that this is what white space is. Alright, you guys, welcome back. So my idea here is to open up the file as we take as an argument. So let's start there. Let's say we have an int 8 which holds a file, and let's also create an int 8 index. And if we don't have any arguments, command line arguments, in that case we need to return an error presenting the usage. And let's say we give the name of the executable, and then file name .c. So that is how it's going to be used, and this is the argv like so, and we return -1. Okay, but in every other case we are going to calculate the index by taking argc -1, and the file is going to be argv at that index. So if we have one argument, argc is going to be 3. No, it's going to be 2. And argc -1 is 1, and argv1 is this argument. And if we have more arguments, so let's say we have some switches here or whatever, then the last thing will still be the file. Because when we execute this thing, I'm not sure exactly how the syntax is. We will figure that out later. But my guess is all the parameters will be here and the file name at the end, because that's how it's usually done. So this will work even if we don't support those things yet. Alright, and the idea is we don't open up the file in the usual manner and use read, etc. to go through it, because this is probably going to be quite a large file, and I want to take every line and put it into a data structure. So we are going to use memory map, a memory mapped file. And if we go to the man page for mmap, so basically we open up the file at its entirety, and this will let the operating system read in the file and put it in some memory location and return a pointer. So we will be able to access the whole file at once. And that is what I want to do. So in that case, the address is probably 0 and the length 2, I guess. Protection, I'm not sure what it is. Flags, let's copy this thing and sysmman.h. So sysmman.h, and we can go here and add a comment, and then we can paste this thing here. So let's see. It takes an FD as an argument, so probably we need to open the file first. Okay, so let's create an int32 FD and assign int ret. And then we set our ret equal to open, and we take the file and we want to open it as let's see, read only, rd only, and I guess that's all. And if ret is less than 3, which means it's an error, then we can just print some error message. Let's see what it says if we try to do cpp some file.c. cc1 fatal error cc1. I'm not sure what that is. Maybe it's the actual path name of this cpp link, but let's skip that for now. Let's just copy this thing without the colors. I don't like colors in that regard, so we can do this, a new line, and we paste this in. And we return -2. So maybe we can use different return values for different errors. And otherwise we can just copy this thing. So fd will be equal to the 4-byte ret, like so. Alright, so now the file is open. Address length, that's probably 0. And we need to store the address somehow. So this is going to be an int8 pointer. Let's just call it pointer for now. So the pointer is going to be equal to mmap, and let's set the first 2 to 0. I'm not sure that's the correct way, but let's try that. And then we have some protection and some flags. I'm not sure what that is. We need to figure that out. So let's just do this for now. And then we have the FD and some offset. So let's say this is our FD, and offset can probably be 0. And if we let's assert that we have a pointer. Okay, so let's figure out what these x's should be. So first we have the protection. Pages may be executed, read, written, may not be accessed. So we want the protection read. That's easy enough. So let's put it right here. And what's the other X? Flags. Share this mapping. No, we don't want to share it. Private. Create a private copy on right mapping. I guess we want this. We're not going to write to it anyway, but we need to choose something. But we probably need more flags than that. Map 32 bits. Put the mapping into the first 2 gigabytes of the process address space. This flag is supported on an x86-64. Okay, that's not interesting. Anonymous. It's not backed by a file. This is backed by a file. Deny write. Executable. Map fixed. Don't interpret address as a hint. Place the mapping exactly at the address. We don't need that. Grows down. Huge. No. Non-blocking. No reserve. Populate. Maybe that's good to have. Map stack, map sync. Don't clear anonymous pages. Right. If address is null, alright, so let's see if this works, and then we just unmap, and we have the length. I wonder if we need the length, or if it can figure that out by itself. We'll see. Okay, they have an example here. No length arg display to end of file. Okay, that's good. Or maybe they do it manually here. st size minus offset. Length plus offset minus p offset. Private. But this is not backed by a file. So that's not really our example anyway. Let's try this out. So if we have a pointer, let's print the value of the pointer. So 0x% dot 08x. And let's print some value at that position as well. 0x% $02 HHX, something like this. This means that we print 32-bit value, and this means 8-bit value. And how do we differentiate between printing the address of the pointer or the value at that address? Well, in this case we just say the integer of pointer, and at the other case we want this to be a char, and we want to dereference the pointer, and then we'll just unmap we unmap the pointer with a 0 size, I guess. I wonder what the return value of this munmap is. I did not read that. Return 0. Okay. So we can do this. We can set ret equal to this, and then we can assert that ret is 0, just so we see what happens a little bit. And by the way, let's also, I guess we can close the file after this point. I think that's how it works. Try that at least. Well, let's see if it works. By the way, we have not created a make file yet to handle the compilations. So let's do that. We have these. So we create a make file, and I'll make this really simple. We might have some flags. We might have some LD flags for the linking. And we're going to compile we want to create cpp.o from cpp.c. And we do that by running our compiler. So let's see, and we might have some flags, and we want to run it with -c, and we want to take the input file, and when we have this, we can create our cpp from cpp.o, cc with our flags. And we want to have our input file, but also birch utils, birchutils.o, as well as the output file, which is this, and all is going to be CPP. We can also create some clean function. It will just remove CPP and all.o files, and this needs to be marked as phony since it doesn't produce anything. Alright, something like this. And let's say the flags are no optimizations. It's a good start. Let's set the standard to C23. And if you run an older version, as I said before, let this be removed. And LD flags, I don't think we need anything there, right? But we can still put it here just in case. In case we need it later, that is. Alright, let's see if this thing compiles. It most certainly did not. Conflicting types for int32. Have long unsigned int. Okay, so maybe it just needs to be long then. It's weird actually that unsigned long int is okay, but unsigned long int is not okay. That's pretty weird. Well, whatever. Maybe I have it defined already in birchutils. Let's double check. If we go to birchutils and birchutils.h, yes, we have those defined. Okay. So let's just remove these. And okay, it's about open. We need some includes. This one, which I can never remember. Map populate is undeclared. That's a little bit weird. User include as generic mman common.h. And bits mman map flags generic.h. Not sure if we should include those. maybe it's better to just remove that thing, because I don't think we really need it. And what else did it complain about? Assert. So we need to include, let's see what we need for assert. We need assert.h, but we also need rnumber.h, and we need to define a new source. It's really not necessary for assert itself, but for assert p error that we might also use. So close unistd. Alright, now I think this will compile. Yes, it did. But will it work? Right, we need to have some file name. Let's run it on... let's make a copy of our H file, just to be sure. Oh, segmentation fault. Huh. I did not see that one coming. How can it be a segmentation fault? Let's see what we got here. If argc is less than 2, then this. But in our case, argc is 2, which means idx will be 1, and the file will be argv1. But this is an int 8. Is that the thing, maybe? Maybe we need to create, but it shouldn't seg fault, right? This should be 1. And then we open the file, check if it fails, and then we do this, and then we do the print. And we give it the pointer, and this is the hex representation of the char. Well, let's try it first. Let's do this trace. So let's see. We do the mmap, but we get an inval. Okay, we get -1, and that is also. I just checked if this was positive, but actually we need to make sure that pointer is positive and that pointer is not less than 0. Can it actually be less than 0? Isn't that pointer unsigned? Maybe we should actually do ret instead. I guess we should. So this will be an integer. And then we can check the ret. And same here, the ret. And if this goes through, then we can set our pointer equal to the int8 of ret. I guess that should be possible. Maybe we need to take the route through an intermediary pointer, but let's see what it says. No? Okay, it was okay. Still segfault though. Invalid argument. Close 3. But why does it survive the assertion? Did it really update? So we assert that ret must be non-zero, which it is, or we should have and there. Those logical operators, eh? So now we should get our own error, right? Yeah. Okay, and why did it fail? Did it say? Invalid argument. I guess that has to do with, let's see, where are we? Prot read, prot write, map private, map anon. That's not what I said. Maybe this is something else. Yeah, that's after. This is my mmap. So I do protection read map private. So maybe it's this 0 here. Maybe we need to specify the length of the file. Alright, so we need to do a stat, or what's it called? lstat. No, that's on path name. fstat, that's on an fd. And then we get a struct stat buff back. So this is to check the length of the file. So we need sysstat.h. So let's see. Struct stat sbuff. So we can start by zeroing out that thing. And this is a function from the Birch utils. So we'll take the sbuff and we'll take the size of struct stat. Like so. And before we, no, after we have opened the file, we will run ret is equal to fstat. And we give the integer value of the fd and the buffer. So we give the address of stat buff. And what's the return value? On success, 0 is returned. So let's just, well, at this point we can probably assert that we have a ret. now we should have access to the file size. How does this structure look? I guess it's in somewhere else. Is it man 5? Or is it 7? I can't remember where we have those structures and stuff. Type. Okay, so man 3 type is that. Here we go. Block size, total size in bytes. So ST size. So instead of the 0, we can give the integer value of statbuff dot st size. All right, let's see if this becomes something better. Expected. Oh, that's not right. Statbuff undeclared. What do I call it? sbuff perhaps. Yes, sbuff. So this should be gone. This should just be sbuff and sbuff like so. Compile. Let's see if it works. I searched in ret file at line 43. So the stat file failed, or what? Let's see. 43. Yeah. How can the fstat fail? That's pretty weird, no? Maybe I did the assertion wrong. Yeah, this should be 0. Okay, this still fails. Is it the same error? No, now we get something. So why do we get that assertion error? Because ret is obviously non-zero. Maybe, and ret is not less than 0. Why does that happen? Am I thinking entirely wrong here? Because this is a non-zero value, so this must be true. And we also assert that ret is not less than 0. Maybe we can do something else. What if we check if ret is more or equal to? No, it should be more than 0, which means we don't really need this one. This should work. Why? Okay, we get such a large address that it, let's see if we do dec on this one. No. Never mind, it's probably a large, such a large value that it wraps around. So let's just say it should not be equal to -1. That should be okay. Okay, now we're at now the unmap fails because we still have the 0 here when we shouldn't. We should have the sbuff.st size here as well. And now, ladies and gentlemen, I believe it should work. Alright, so this is the address that the operating system is nice enough to allocate for us. And this is the first byte read from that address. And 2f, what might that be? 0x2f, 47. If we try to print x2f as a character, what do we get? We get a slash. And if we check this test.h, it begins with a slash. Wow! Alright, so we have the file. We do have the entire file. That's pretty nice, no? Okay, so now we can finally start to do stuff. Even though we have closed the file, we still have access to the entire contents in a memory buffer, which is nice. So what is the logical next step? What we want to do is we want to go through this file and grab each line of the file and put in some kind of data structure. So let's think a little bit on how this data structure might look. So let's see here. It's going to be a struct, that's for sure. And let's call this S-line. And what do we have inside of here? First, we need to have some tag, because we can have different things. It's not only character lines that I want to put in here. Because if it starts with a hash sign, so we have something like define constant 5, then I want to have some token or something for this. So let's first say that we have type, and let's call this a tag. And we need to define what a type is. And let's see. Then we can have one out of many things. So let's say we have an union, which means that one of these will be true. So we might have a, let's call this a string pointer, but we might also have token pointer, a toke pointer, and maybe other stuff as well, but let's start there. And we also want to annotate which line number this is, so we can produce nice error messages. So let's say this is an int 32 line number, and maybe we need other stuff as well, but let's start there. And I want to type def this struct s line and call the data type just line. So what is this tag, this type data thing? I want to make it an enum, e type. So let's say this can be either well, it can be a string, or it can be let's see, let's do it like this. Let's do big letters, so then we can call it token here so it doesn't conflict. And we will type def this as an enum e type, and it will become just type. So now we need to define what a token is. And let's just do some dummy thing for now, because this we will define more thoroughly later on. But let's say we have a token, and for now let's just have something in here for nothing. Type def struct s token as token. Okay. Right. So we need to have a constructor function for this. So it's going to return a line pointer, and it's going to be named make line. And what do we need? We need to know the type, and we need to have a, let's say this is a void pointer, and an int32 for the line number. Let's move this down to the rest of the functions. Okay. So my idea is we will go through this in several rounds. First, we will go through the memory mapped file and just put everything as string pointers. And then we can go through it and take care of everything that ends with a backslash and collapse those into one line. And then we can go through everything, taking care of the tokens, so we can identify definitions and if, defs, and includes. And then we can take action out of these includes, like replacing text and whatnot. I think that's a good enough idea. So our first thing will be to turn our memory mapped file into these lines, which basically means that we need to have a function which will return a bunch of lines. And let's call this parse file or something. And it's going to take an int 8 star, which is this entire memory mapped thing. And we'll just go through this and copy everything into lines. So first of all, can we figure out how many lines we need? I guess we need as many lines as we have new line characters plus 1. Because if we have 2 lines, we might just have 1 new line character. So let's create a function that counts these. So let's say this returns an int32, and we can call it count char, because then we can count other things than just new lines. We can count any char basically. So we need to know the memory area, and we need to know the character we want to count. We also need to know the size, and same here with the parse file. We need to know the size in bytes. So let's start with this count char kind of thing. So let's say we have an int32 n for the number of lines. And after we have closed the input file, we can do this. So n is going to be equal to count char, and we want to use the pointer as a memory area. We want to use the, let's see, the integer version. No, not the integer version. We want to use the int32 version of the sbuff.st size, and in between we want to have this new line character as an int 8. And we can assert that this is not 0. And then we can increase it by 1, which means that then we know how many lines it is. And let's print that out as well. So n is equal to this. Like so. And now we only need to create this function. So it's going to be an int32 count char. It's going to take an int8 mem space, an int8 character, and an int32, let's see, file length. So we're going to have an int32 n. We need to have a pointer, so int8 p. And I guess we just go through the whole file in a loop. So for we set n to 0, we set p equal to mem space. We want to loop as long as p is less than mem space plus file n. And at each iteration we want to increase p. And if the current p is equal to our character, then we increase n. And then we return n. I think that should work. Compiles. Let's see what happens. N is equal to 23. And if we count the lines of test.h, 22 it says here. Okay, what if we end with a new line? Then this one says 23. And this one says 24. Okay, I guess we shouldn't increase it then. Easy enough to fix though. Just remove this. So if it works, we should get 23, which we do. Okay, that's nice. We are getting there little by little. So after the break, we are going to continue, and then we are going to turn this whole memory mapped area into our new line structures. So see you just in a bit. All right, you guys, welcome back. So before we begin with the first parsing function, I want to refactor this just a tiny bit. I want to take all the stuff where we load in the file and put it inside of its own function, because we are going to need to do it several times in case of includes and stuff. So let's say that we have a function which returns an int8, which is a memory area. And let's call this read file, perhaps. And it's going to take well, just an int 8 for the file in question should be enough, right? So how do we do this? I guess we will just create the function here, int 8 read file, int 8 what would you call it here, file, and we are going to need a couple of things. Let's see, idx, well, basically all of this, right? And then we can probably just we can take most of this. Let's take this here and move it to the top, and then we can just copy all of this, basically, at least down to here. We'll take this and we'll paste it here, and this n we can put back because it has other purposes. Right, because that takes care of the counting. File is equal to this. We still need the pointer here as well, though. So int 8 pointer. But we're gonna get the pointer by calling our function. So read file, and we provide the file name like this. And then we should be able to do the rest of this, I think. What we can do is we can make sure that we have a pointer at this point. A pointer at this point. Okay, so let's go through this here and see what we got. So we zero it out. The index needs to be calculated inside of main and not there. So something like this. And then we open the file, and if yeah, I guess we can do this like this, but we're not going to return -1. In this case, we will just return 0, which is casted to an int 8. Otherwise, we do this, and we start the file, we do all of this stuff right here. Right. So at this point, we can simply return the pointer. And I think this should be enough. Let's see if it still compiles. No. sbuff. Right. We need to, because this stat buffer, it contains the size of the file in bytes, and that is needed. So we can't just return an int 8. We need to return a tuple of this int 8 pointer as well as the size in bytes. And maybe we should even return the number of lines. Yeah, I think we shall. So let's put this n back here again. And let's go here and we take this part right here. Yeah. We don't need to assert this, since if we include a file, then I guess we can include an empty file. That shouldn't halt the entire compilation process. All right. And this unmap, let's highlight this so we remember it, because here we need to create a function as well, which takes care of this unmapping. Yeah. Okay, so let's define this tuple type, or triple, or whatever it's called. So we're gonna have a struct s. Let's call it tuple anyway. And we're gonna have an int 8, which is, what should we call this? Mem space. We're gonna have an int 32 for the bytes, and an int 32 for the lines. And let's type def this struct s tuple to a tuple type, like so. Let's also make sure that all our data structures are optimized, so we don't have a lot of room between the variables and stuff. So let's say we have a keyword which is called packed, and this is an attribute with the same name, packed. So now we can just say that this enum should be packed. I think this is how we do it, right? Or maybe after. No, this is probably right. So this is going to be packed. And this too. And this too. All right, good. So now that we have this, now we can start parsing the thing. So we have this first thing which parses the file. By the way, we need to return the right thing. So we need to have some buffer that we can return. So let's say we have a static tuple tube, and let's say we have a tuple pointer like this. That doesn't look right. Let's say tuple pointer like this. So now at the end here, where we have all the information we need, now we can start filling out this structure. So our tube dot mem space is going to be equal to the pointer. Our tube dot bytes is going to be equal to 32 of sbuff.st size, and our tuple.lines is going to be equal to n. And our tuple pointer should point at the address of tup. And now we should be able to return tuple pointer like this. Alright. So after we have read in the file, and by the way, we need to have the same thing here. So let's say we have a tuple pointer, and we will set the tuple pointer equal to this. And we will assert that we have a tuple pointer, and instead of printing n here, we will print tuple pointer lines. And instead of just printing pointer, it'll be tuple pointer memspace. And same here with this one, tuple pointer memspace. And when we unmap, we're not going to go to sbuff st size. We are going to tuple pointer bytes. Alright, I think this is going to work. We need to redeclare the signature, or alter the signature. So this is going to return a tuple star. Now it should compile. Okay. Conflicting types. Oh, maybe I forgot to change in the C file. Yeah. So tuple star. And now it should compile. Almost. We can't return a 0 like that. Instead, we need to return a tuple casted 0 like this. Ret is undeclared. Let's declare it. So ret should be a signed integer ret. Alright, let's see if it works. Test.h. Assertion of ret failed. Didn't we remove that? 83. Okay. Pointer. This should be something else, right? Tuple pointer memspace. This is it. Alright, so now we're back where we started, but a little bit more structured. Okay, that's good. What else? What else? What else? Well, now we can create this parsing function. And after we have done that, I'm going to have several functions which take the same input, basically. So it will return a line, and let's say we have a stage 1, for instance, and it's going to take a line as input. And maybe also the number of lines. And then we're going to create a bunch of these. So we're going to do different stages where we go through and improve the file in each stage by altering these lines. So one stage, for instance, could be that we collapse all the lines that ends in a backslash. One stage could be that we take everything starting with a hash sign and we transform that into tokens instead. And one stage can be, for instance, if we have a define somewhere, that we copy and paste the value of that definition to each line that has that identifier somehow. And maybe also do other stuff here. But that's a general idea anyway. But before we can do any of that, we need to parse the entire file. Yes. So let's start there. And I guess this int32 right here, is that the lines or the number of bytes? I guess it's the number of lines, right? Maybe not. I think maybe the number of bytes is more sensible, since we want to know when we have gone through the entire file. Yeah. And maybe we should also have some kind of void function, which, maybe not void, maybe line, all stages or something, with the same structure or signature. Something like this. I think this will be good. And I also want to create a symbol table. Because when we find a define, for instance, it's going to have an identifier and a value. And I want to put that inside of a data structure. So maybe we can create that first. So struct s sim table. Or maybe we can spell it out. Symbol table. We're gonna have an int8 identifier. And what's the value gonna be? It can be a string, but it can also be other stuff. Maybe we can create a union here too. So we can have something like I guess the most optimized way would be to have an int8 pointer so we can allocate this specifically. So let's say that this is the string val, and we might also have an int val, and these are the same size, so that's good. And I guess this is the entire thing. I want it packed though. And maybe we also need to pack the unions. I'm not sure about that, but let's do it. And then we can type def struct s symbol table, and this is going to be our symbol table data type. Okay, one other thing, and this is, if you're following along in this project, this is optional. I wanna, let's see if I can access this repo. So from the same repo that we got Birch utils, I have something called a lock, which is a project I did maybe 6 months ago, where I coded my own dynamic memory allocator. So basically my own malloc and free and stuff like that. And I want to use this when I code this, but this is written for 32-bit. I did, however, include this. So if you want to use this and you have a 64-bit system, then you can delete the heap.asm and rename this heap 64-bit to heap.asm. And then everything should work. But if you experience problems, or if you want to use the regular malloc, then you can skip that part, and instead in the code you can add 2 things. You can do, maybe we have some macros here somewhere. Yes, here. You can do define alloc, which is the name of my function. And you can say that if this code finds any alloc, it's going to run malloc with the same argument. And if it finds destroy, which is my name for free, then you run free of the same argument. If you have these 2 lines, then you don't need my library, and the rest of the code will work anyway. But if you want to use it, we need to do something like this. So you're going to do something like this. You go into this directory, alloc, on the repo drbirch.com, and you download this zip file. And then you can put it inside of the same directory as your project. As I have done here, I have the alloc.zip. So I can do unzip alloc.zip. And I can remove the zip file. Then I go to this directory, and I will remove this heap 64 because I don't need it. But you should instead remove heap.asm and rename this to heap.asm. And you also need to install nasm, which is the assembler. And you can do that by the regular apt-get install NASM. Otherwise, if you're running Windows, you can just search for NASM download. And this is the one, I think. And then you just download and install NASM. And we're not going to talk specifically of assembler in this episode. I just wanted you to know how to use the library. Okay, let me check through this make file real quick. Alright, I think we can do the same as we did with the other one. So we just run make, and we don't need to care about these. Okay, so it makes a binary here. Maybe because it contains this main function, which we don't need, because I never really turned this into a library per se. So if we go into the C file, we should just be able to comment out the main. And same in the .h file, we can just delete this or comment out this main. And alter the make file slightly. So this right here, we can comment out these two and remove a lock here. So if we run make, now we will just, okay, we need to do one more thing. We can remove clean here, and we say we want heap.o and we want a lock.o, because it's the object files I'm after. So now we have a lock.o and heap.o and a lock.h. So now we can go to our makefile for this project, and let's create a variable, call it libraries, and we can take this virtual stuff and put here, and after it we can say a lock.o, a lock heap.o, and that should be enough, I think. Let's see if our project still compiles. Yeah, I think it does, except that I made a typo. This should be line. Undefined reference to 0. Let's see, what did it do? Oh, I forgot to add the variable. Because we created libs, but we never used them. So let's add libs right here. And let's also, inside of our cpp.h, we should include alloc.h. And now I believe everything should work. Packed redefine. Okay, I have packed in the alloc project, so we can remove this definition because it's the same. All right. Let's see that it still works. Text.h. Yes, it does. All right. So now we have access to memory allocator functions, which I think at least works better than the regular malloc, more optimized, faster, and nicer. Okay, let's write this parse function. So it's called parse file. It takes in the memory space of that file and the number of bytes. And what it should do is create lines for everything. In this line data structure, it contains a tag, string and token, yes, and then one of these pointers and the line number. Okay, should be simple enough. So let's go to the beginning of this file. And this is going to be line parse file. It's going to take an int 8 star for the memory space. So let's see. Yeah, we can call it mem space. And then an int 32 num bytes. We're gonna have at least one pointer. And we're gonna have a counter of some sort, so let's call it n. And we need to find the new line and act upon that. So let's say that by the way, let's assert that we have a mem space and that we have a number of bytes which is not 0. And then we can set p equal to find char. So we want to search the mem space for the first new line character. And we don't have this find char, we need to define it. We can create the signature. So it's going to return an int 8, find char. It's going to take in an int 8 and the character that we want to have, that's also an int 8. So how do we know that we don't look too far? Well, let's worry about that in a little while. So let's start without taking that into account. So we're gonna have a int8 find char and int8 source int8c, and we need a pointer. For loop where we set p equal to the source. We're gonna loop as long as p is not 0. And as long as p is not equal to the character. And at each iteration, we are going to increase p. And we don't need a body here because it will stop when p finds a null byte or when it finds a correct character. So if p is equal to a character, in that case we return p, because we want to find the position of that character. And otherwise we just return 0. And we need to cast this into an int8. Alright, so this should work, but it does not take into account that we might read past the end of this mem space. So how do we make sure we don't? Well, basically we need to pass that number of bytes as well. Let's say that we have an int 32. What should we call this? Well, it's the size of the mem space. So we need to have an int 32n. And at the beginning we set n equal to the size. At each iteration we will decrease n. And when n is 0, we also need to stop. So something like this. Maybe we can make it a little bit more structured by putting this stuff in parentheses. So we see clearly that there are 3 different conditions. As long as n is positive, we continue. As long as p is not 0, we continue. And as long as p is not equal to what we're looking for, we also continue. Okay, I think this is going to work. And maybe we should we need to know how many bytes in we are. So we can calculate it. First we need to check that we have a p. If we don't have a p, if we don't have a p here in the beginning, then we're in trouble, right? So that in that case we can return an error, line 0. And maybe we need to clean up some stuff that we add later. What about this? So we can put in those brackets. Okay, so however, if we have a p, then we should be able to calculate this stuff by taking p minus the mem space. So then we know how many bytes we have read in this far. So maybe we should have something like bytes left or something. And I guess we need to cast this explicitly. And then we can say bytes left minus equal to the n. And maybe we should use bytes left. Oops, that was not the right thing. Bytes left here as well. And let's set it bytes left equal to num bytes from the beginning. Alright, so now we have found the first new line. So what we want to do now is we want to replace that new line with a 0. And then we want to copy the line into what? Into a new line structure. And what does the constructor of that line function take? Did we create make line? No. We did define it up here, but we never did anything more with it. And this takes in the type of the line. So if it's a string or if it's token, it takes in a pointer of some sort. Can be different kinds. And this is a line number. So let's create this function real quick. We'll return a line pointer, make line, and first we have a type. Let's just call this kind or something. Then we have a pointer, so void pointer. And finally we have the int 32 line number. And if we don't have a kind, or we don't have a pointer, or we don't have a line return an error. Otherwise we should allocate this thing. So we need a line pointer, let's call it P. We need an int16 size, where the size is equal to size of struct s line. P is equal to, and here comes the alloc. So let's cast this into a line. And alloc, and I think this takes an int16. Let's double check in the header file. Alloc. And in 32, okay. So we need to cast this into an int32 size. And we can assert that we have a P, because if we don't, something is terribly wrong at this point. We can zero the P with the size. And now we just need to put the stuff in it. So first the kind. So P and token type, or what did we call it? Okay, the tag is what we named it. So the P tag is the kind. And before we can, well, this depends on the kind. So if kind is equal to, what do we have? We have string or token. So if it's equal to string, then we do P string pointer is equal to an int8 of the pointer. And if kind is equal to token, then we take the token pointer of P and we set it equal to the token star of our pointer. And if something else happens, we'll return an error. And then we copy the new line. I mean the line number. So P line number is equal to line number. I think we named it line number. Yes. And then we can just return P. Simple enough. So now we have a way of creating this line data type, or line object. I think it would be easiest if we copy it to some intermediary thing. Let's say we have a temp of size 256. And at this point we zero out our temp 256. Then we do a string copy. And we need to define this string copy. I'm gonna create my own function for it later on, but for now we'll just do this. So string copy of x. Let's see here. The destination source. Let's do destination source size. And what we're gonna do is we're gonna call strncopy, and we're gonna cast into a char the destination. We'll cast into a char the source, and we'll cast into a regular integer the size. Okay, so now we have a string copy that we can use, and we want to copy into our TMP. Maybe like this. And we want to copy from let's create an additional pointer. So we have the P, but we also have the start. And let's say the start from the start is equal to the mem space. So now we can copy from the start. And do we know how many? Yeah, the n is the number of bytes. So we can just give the n here. And now TMP contains this thing. Maybe we don't make it like this, because we need to allocate for it anyway. So why not make it a pointer instead? And we know the size, so TMP can be equal to alloc of n plus 1. So we have some room, and this will be n plus 1. And we can remove this. And this. And this. Alright. So now before we create this line number structure, we need to figure out what kind this is. And if it starts with a hashtag, then it is a token. But we should also take a white space into account. How did we do? We had some white space thing, didn't we? Bool white space, okay. Well, we can do something like this. What if we were to do while let's see, while white space and this takes in a single character, so we can say start or maybe P. No, let's preserve P. Let's say start. So as long as it's white space, the beginning of the line is white space, and start is not equal to a hash symbol, then we will just loop. Maybe we can do this. Start plus plus, like so. So if we hit something which is not white space, we stop. If we hit the hash symbol, we stop. Okay, so now start should be able to should be equal to either a hash or any other stuff, but not the white space. Which means we can do if start is equal to the hash symbol. Let's also create a type, and let's call this kind. So if we have encountered this white hash symbol, in that case we set kind equal to token. Otherwise, kind is string. And now we should be able to create our thing, right? Let's say we have a line. The line is equal to make line. And what arguments did that take? Kind pointer line number. So we need to keep track of the line numbers as well. So let's say we have an int32 line, and the line starts at 1, So the kind is the kind, and then we need to transform into void our maybe we need to deal with this differently depending on what kind it is. So if it's a string, then this is rather easy. Then we can just say that this is the TMP. And we also give it a line number. But we have a data type which is called line. So let's say this is the current line. And then we can increase the current line. And we can't create tokens yet, so let's just say this is 0 for now, and then we mark it. But this shouldn't just return one line, it should return a whole array of lines, or some group of lines at least. So how to do that? Maybe we can make this a pointer to a pointer instead. Because we know how many lines there are, which means we should be able to pre-allocate those pointers. So let's say that we have something like this. And lines is equal to, maybe we need to do the size calculation specifically. We don't use n before down here, so let's borrow n. So n is equal to the size of a line pointer times well, we need to tell it how many lines we have. So let's give another int 32, and this is num lines. forget to update this thing. Parse file, it's gonna take pointer to pointer, and we need an additional parameter. Okay, I think this is a good enough solution. So we multiply this by the number of lines, which we have already calculated beforehand. And now we can allocate, so lines is equal to line double star alloc n. Insert lines. Okay. So we need to keep track of the current index as well then. Or do we now? We can actually make use of the line counter that we already have, the current line. So let's wait with increasing this. But this is 1 indexed, and we need to use a 0 index. So just to make it explicit, let's create an index like this. Where index is the current line minus 1. And now we can set the lines of index to our ln. And this is how we create one of these structures. So basically what we need to do is make a loop out of this. So here somewhere. And maybe we can say, as long as we still have some num-bytes, let's do this instead. And let's do some if check, which will break if that condition is true. So where do we decrease? Here. Bytes left minus n. So let's check if bytes left is less than n, because then we will go on minus, or less or equal. In that case we can set continuation to false, so we know that we should quit. While difficult word to spell, continuation. Pick the best variable names, don't I? So like this. So before before we begin the loop, we will set the continuation to true. And here it sets to false, which means that this is the last iteration. Maybe that's all we need. P is equal to find your mem space. We set start equal to mem space. We should use start here instead. And then we need to remember to set the start down here, the new start, to p+1. And let's do p++p. A lot of moving parts here, right? But I think this is going to work. We might need to troubleshoot it a little bit. But in general, I think it will work. And before we return here, we need to free up some stuff. This will result in an exit anyway, but let's just destroy the lines at least. That's the big structure. Yeah, I think this will pretty much work. At the end, we're going to return the lines. So how we're going to use this, we're going to have a line double star lines. Lines is equal to parse file. And what are the arguments? Int 8, int 32, int 32. So it'll be the tuple pointer mem space. And then we need the number of lines. So that's tuple pointer lines and the number of bytes. So that's the tuple pointer num bytes, I think. Or just bytes. All right, Let's see if this works. Conflicting types, find char. So we have source, we have C, we have size. Find char. Okay, in 8. So we added the int 32. Okay guys, I think that will be all for today. Before we end though, I just want to shout out a little bit about my course, a C compiler in JavaScript. If you go to courses.drbirch.com, you can read more about this super interesting project. It's a 15-episode course, and it's a very good way. If you, for example, are a web developer, want to learn more about C, this is a great way of doing that, because you will learn from the ground. And yeah, I hope you like this project we've been coding on today. And if you like this episode, please like and subscribe and hype. And I will soon be back with the continuation of this project. Thanks for watching. Thanks for today.